When we talk about black holes, we think of invisible forces that distort space and time. But what if there were one so gigantic that it needed a whole new category just for itself? That is Phoenix A, the largest black hole ever identified, a structure so colossal that it simply cannot be ignored. The light we detect from it today began its journey 8 billion years ago, at a time when Earth did not yet exist as we know it. At the center of one of the brightest clusters in the universe, this cosmic monster not only continues to grow, but also transforms its surroundings in ways that scientists are still trying to understand. With numbers that defy any comparison and a cosmic influence that stretches across absurd distances, Phoenix A has become a true landmark in modern astronomy. But grasping its immensity is just the beginning. There is still much more about it that remains to be explored. Have you ever wondered what would happen if our sun, already impressive in size, were just a grain of sand compared to something much larger? In the vast universe that surrounds us, there exists a structure so colossal that it makes our stars seem microscopic. Phoenix A stands out as the largest black hole ever discovered by modern science, silently hovering 8 billion light-years from Earth. This cosmic titan not only challenges our understanding of the galaxy, but also redefines what we once considered extreme within the scale of the universe. To grasp the magnitude of this phenomenon, consider that when the light we observe from it today began its journey toward us, dinosaurs had not yet appeared on our planet. In fact, Earth itself was still in its early stages of formation. Phoenix A remains there, imposing and mysterious, swallowing everything that ventures too close to its invisible boundaries, serving as a silent reminder of the extremes that science is still striving to comprehend. Astrophysicists like Kip Thorne and Andrea Ghez, who won the Nobel Prize for their studies on black holes, would undoubtedly be fascinated by the unique properties of this hidden giant. When we think about the classification of objects in the universe, we usually imagine well-defined categories established by science over decades. But what happens when we encounter something so extraordinary that it requires a category of its own? That is precisely what happened with Phoenix A. This unique celestial object forced astronomers to create an entirely new classification: ultramassive black holes, a category that surpasses in scale and power even the already impressive supermassive black holes we knew until now. Within the vast galaxy of astronomical knowledge, this new classification represents a leap in our understanding of extreme cosmic phenomena. Imagine the shock of scientists realizing that their previous scales were insufficient. It's as if, after decades of studying elephants, we suddenly discovered a species 10 times larger. The international scientific community now faces the formidable challenge of understanding how these titans of the universe behave and what physical laws govern bodies of such unprecedented magnitude. Astronomy books worldwide will need new chapters dedicated to this discovery, which has expanded the boundaries of what we once considered possible. At the heart of one of the most spectacular cosmic displays in the universe lies Phoenix A. This colossal black hole is not isolated. It is the beating heart of the Phoenix cluster, a galactic conglomerate that astonishes any observer. What makes this cluster particularly fascinating to scientists is its extraordinary X-ray luminosity, a glow so intense that it makes it one of the most easily identifiable structures in the vastness of the observable galaxy. It is almost as if nature had created a cosmic beacon to guide us to this marvel. X-ray telescopes, such as NASA's Chandra Observatory, can detect this cluster with remarkable clarity, even from billions of light years away. Amateur astronomers interested in observing extreme cosmic phenomena often begin their studies with clusters like this, using online resources from the Sloan Digital Sky Survey project, which maps distant celestial objects with exceptional precision. This gigantic nursery of galaxies continues to serve as a natural laboratory for understanding the large-scale evolution of the cosmos. There are moments in the history of science that mark true turning points in our understanding of the universe. In 2010, one of these extraordinary moments occurred when researchers finally confirmed the existence of the Phoenix cluster. What had once existed only as a theoretical hypothesis or a hazy point in older telescope images became a measurable and documented reality thanks to technological advances in astronomy. This discovery was not an isolated event, but the result of decades of scientific evolution and refinement of observational instruments. The most astonishing fact? This cluster may contain up to 1,000 galaxies, each with billions of stars, planets, and of course, its own black holes. Think about the scale of that. A single cluster with potentially more stars and grains of sand on all the beaches of Earth. Astronomers seeking to study the formation and evolution of galaxies find in the Phoenix cluster a true scientific treasure, as it serves as a kind of cosmic laboratory, where various evolutionary stages of galaxies can be observed simultaneously. For those interested in following similar discoveries, the monthly publications of the Astrophysical Journal frequently bring new revelations about these distant giants of the universe. In a universe of extreme cosmic phenomena, few are as impressive as an active galactic nucleus, AGN. The galaxy that hosts Phoenix A is not only remarkable for its size, it harbors at its core an AGN, a true reactor of unimaginable proportions. This super-energetic nucleus emits such colossal amounts of energy that even our most powerful nuclear reactors would seem like mere matchsticks flickering in the darkness of the galaxy. It is as if nature had built a universal power plant at the heart of the system. Every second, Phoenix A's AGN releases enough energy to power all of Earth's civilizations for millions of years. Scientists studying these active nuclei often use radio telescopes, such as a very large array in New Mexico or ALMA in Chile, to detect the radio waves emitted by these objects. These observations help science understand how matter behaves under extreme conditions that we could never replicate in terrestrial laboratories, expanding our understanding of the limits of physics in the observable universe. When we try to grasp the size and mass of Phoenix A, mathematics becomes almost poetic in its grandeur. This cosmic giant has an estimated mass of 100 billion times that of our sun. To put this into perspective within our own galaxy, if our sun were the size of an orange, Phoenix A would be like a mountain the size of Mount Everest. Science presents us with numbers that challenge our ability to visualize, as we're used to the everyday scales of our terrestrial world. The event horizon of this colossal black hole, the invisible boundary from which nothing, not even light, can escape, measures approximately 590 billion kilometers in diameter. That's about 4,000 times the distance between Earth and the Sun. If you try to map the circumference on a cosmic scale, you would need such a reduced scale that our entire solar system would appear as nothing more than a microscopic. Astronomers like Neil deGrasse Tyson and Brian Cox often use analogies in their lectures to translate these cosmic dimensions for the general public, comparing Phoenix A to familiar objects magnified trillions of times in an attempt to help our brains process what mere numbers alone cannot convey. Now that we understand the absurd size of Phoenix A, a fascinating question arises. How long would it take to traverse its event horizon? If the speed of light is already the fastest in the universe, imagine what it means for an object to be so massive that even light cannot cross it quickly. To complete a full orbit around this colossal black hole, a beam of light would take approximately 71 days. That might sound abstract, so let's put it into perspective. Sunlight takes only 8 minutes to reach Earth. Meanwhile, light traveling around Phoenix, it would take more than 2 whole months. If a hypothetical traveler could survive near this cosmic monster and attempted to complete this journey in a spacecraft moving at the speed of light, they would experience such extreme time dilation that, by the time they finished, the universe around them could have changed dramatically. These mind-boggling numbers remind us of how much of the universe remains unknown and incomprehensible. Yet, even in the presence of such an overwhelming gravitational force, something truly surprising is happening nearby. A stellar nursery is unexpectedly forming, defying our expectations of what can exist in such an extreme environment. If there's one thing science has taught us about black holes, it's that they are voracious devourers. However, Phoenix A challenges this notion by exhibiting an intriguing phenomenon. It is surrounded by an environment of intense star formation. While the Milky Way produces at most 1 star per year, the galaxy hosting Phoenix A astonishingly generates 740 stars annually. This defies logic. After all, a black hole of this magnitude should suppress the creation of new stars, not encourage it. But scientists believe that the reason for this anomaly lies in the interaction between the radiation emitted by Phoenix A and the surrounding gas. Instead of merely consuming matter, it can also compress gas clouds, triggering new gravitational collapses that lead to star formation. Think of it as a giant ocean wave. As it surges forward, it sweeps everything in its path, But when it recedes, it leaves behind seashells, seaweed, and other remnants. Phoenix A behaves a similar way. Its colossal presence alters the surrounding matter dynamics, causing new stars to be born even under its overwhelming gravitational influence. But have these giants of the universe always existed? Or is their origin tied to even older and more mysterious cosmic events? Phoenix A didn't appear out of nowhere. Like any other black hole, it required an initial cosmic event to come into existence. But ultramassive black holes like this one raise a major question. How did something so colossal reach this size? Scientists are working with several hypotheses. One suggests that these cosmic giants began as smaller black holes that, over billions of years, merged with others and absorbed absurd amounts of matter. Another possibility is that they formed directly from the gravitational collapse of enormous gas clouds in the early universe, creating already massive black holes from the start. Whatever the definitive explanation may be, one thing is certain. These monsters continue to grow and shape the galaxies around them. With each new discovery, we realize that the universe is filled with secrets buried in time, some so ancient that they may have formed shortly after the Big Bang. And just when we think we've seen it all, something even more spectacular emerges to challenge our understanding. The existence of Phoenix A is clear proof that the universe still holds secrets that defy our understanding. If such a colossal black hole went unnoticed until recently, what else might be hidden in the vastness of the cosmos? With each new generation of telescopes and more advanced sensors, our ability to observe the farthest reaches of the universe expands. Objects that once appeared as mere blurs now reveal astonishing details, which means there is still much more to uncover. Science is only beginning to understand ultramassive black holes, and the questions they raise are as deep as their overwhelming gravity. If Phoenix A has been found, it means there are others like it, perhaps even larger, drifting through the universe, waiting to be detected. The question now is no longer if we will find more of these colossal entities, but when and where. Phoenix A shows us that the universe still has much to reveal. If a black hole of this size went unnoticed for so long, imagine how many other colossal structures might be hidden, waiting to be discovered. With each technological breakthrough, more powerful telescopes allow us to see deeper into the cosmos, expanding our understanding of these invisible giants. But black holes aren't the only extreme phenomena that challenge our understanding. There are even more violent cosmic events, such as neutron star collisions, which release an absurd amount of energy and create some of the rarest elements in the universe. If you want to understand what happens when these stars collide, watch the video Kilonova. What happens when two neutron stars collide? And if you want to keep exploring the secrets of the universe, subscribe to the channel and turn on notifications. There's much more to come